Welcome to a video tutorial on some data cleaning techniques, sometimes called data manipulation, but don't think of this as manipulating data. A lot of times people think manipulating data has a bad connotation, and it is when you're actually manipulating things, i.e. changing things to, get the outcomes you want. That's not what we're doing here. What we're doing is we're going to clean up our data and we're going to move our data around and, maybe add some variables and things like that so that we can get it ready to analyze it. So these are just some of the topics that we're going to cover. We want to make sure that however our data is given to us, whether we have it in a Google Sheet or an Excel file or whatever it is, that we can get it ready to import into SAS or any other, R, SPSS, whatever. You need to know the particulars of the software you're working with. So what does it require? Um, you know, can you upload an Excel data file? And if so, does it have to be formatted a certain way? Those are all the types of things you need to know ahead of time so you can get your data cleaned up and ready to import into the software package you're using. We're going to take a look at a scenario where we have our data kind of in multiple places and we want to merge it all together so that we can run analysis on everything all at once. We have to look at what happens when we might have some duplicate entries. And we always want to keep in mind what are the analyses we're going to run. So really you got to start with your research questions. And what research questions do you have? And then what analyses do you have to run on your data to answer those questions? And then based on that, what form does your data have to take in order to run those types of analyses, right? So if you're going to run a chi-square analysis, your data has to be in a certain form. If you're going to run a t, let's say a paired t-test, then your data has to be formatted a certain way. If you're just going to run some summary statistics, then your data has to be formatted a certain way. So those are all the things you have to keep in mind before you try and just upload your data to your software, because it's going to be a lot easier to clean your data, manipulate your data, move stuff around in Excel or Google Sheets than it is once it's in your software package. So let's look at a scenario that we might come across. So for this particular project, you have a bunch of data on judges. So you're given an Excel file that has, almost 200,000 court cases over a 3-year period from 38 different judges. And you have to note that 2 of the judges, right, judges 3 and 4, did not serve in the same court for the entire 3-year period. So that's going to come up where we have to kind of like merge some stuff. So they want you to answer some questions of probability and conditional probability based on this data. You want to kind of rank your judges and figure out who's doing their job, right? So you have to understand, what does it mean to rank a judge? Well, they talk about most cases the verdict stands, and whatever the verdict is, it stands. But some of those cases get appealed, and of those that are appealed, some are reversed. And because appeals are often made as a result of mistakes made by either the judges or the attorneys, but more likely the judges, you want to determine which judges are doing the best job by figuring out which ones basically have the least amount of appeals and of course the least amount of reversals, because if they get to an appeal and it's reversed, that normally means the judge did something wrong. So you kind of want to, the best judges are the ones that don't have very many appeals and have very few reversals. So you want to rank your judges based on that. So down here are all the questions, so to speak, that you want to answer with your data. So remember, we need to keep those in mind when we're playing around with our data. Okay, so let's take a look at the data we're given. You'll notice that we're given the data in 3 tabs because of the 3 different courts. So we have the Common Pleas Court, Judges 1 through 16, the Domestic Relations Courts, Judges 7, 18, 19, but then you'll notice there's Judge 3 again. So Judge 3 worked in both of those courts. And then the Municipal Court, Judges 20 through, looks like 38. But again, we have the repeat of Judge 4. So that's the first problem we have, is that these judges are, coming up in 2 different places. Well, some of the questions they said was, ranking your judges. So to rank your judges, you need them all in one file, right? You need all your judges all together so you can rank them. You'll also notice that, we're calculating the probability of appeal, a reversal, and then this conditional probability of reversal given appeal, and we're doing the exact same thing for all 3 courts. So why do that 3 times when we can do it once for one whole set of judges? So the first thing I would do is I would create a new sheet, and I'm just going to put it in the front because that's where I like it. I'm going to call this merge or whatever, right? It's going to basically be all of my data put together. And so I'm going to copy this first set of judges. I'm not going to copy the total because I don't need that. And I'm going to put it in my merge. And you'll notice that I'm going to put it at the very top because most data analysis programs like SAS and R and things like that, if you're going to import a file, the first row has to be the variable name, and then all the variable, values come underneath it. So you don't want any blank rows. Like if you tried to upload this would be a problem because these first 3 rows would make SAS just not understand what your data is. So I'm going to go to here, and I'm just going to take out the judges, right? I don't need anything else because I already have that header row. And again, I don't need the totals. Paste those in here. And then last but not least, come grab the municipal judges. Of course, you don't need to grab all of these empty cells, but it's just saving me the hassle of having to come back later and put in all the lines, which you don't really need anyways, but just to keep it pretty and easy. Okay, now the next thing we want to do is, get this ready for analyses. We want to be able to rank things. We want to take care of these judges that are listed twice. So the first thing I'm going to do is I'm going to give this a 3A, just so I can keep track of which one was which, and a 4A, right? So I know that these are the ones that came from the different courts. Now, since we're talking about different courts, why don't we take care of that right now? So I'm going to do Alt Insert Column, and I'm going to call this court. And this is going to take care of keeping track of which court these judges were working in, right? So for instance, 1 through 16 were all from the Common Pleas Court. So we're just going to call that Common Pleas, and I'll make it big enough so we can see it. And then again, remember we're just doing 1 through 16. So we can grab this, grab the corner, and 1 through 16 Common Pleas. Then domestic relations is 17 through 19 with that little 3A stuck in there. So go back here and domestic relations, again, 17 through 19, right, with the 3A, double check it. Yep, 17 through 19. And then of course all the rest, 20 through 38 with 4A stuck in there. They were all the municipal court. So if I go here, municipal court, drag that down. And now we've designated which court all of our judges come from. And now we could see this way when you load your data, oftentimes, let's say you wanted to look at the average number of cases that were appealed by the court, per court. So what was the average number that came from the common pleas, the domestic relations, and the municipal? Well, in a lot of analyses programs, you could have like multiple columns and stuff, and it's fine. But what if you want to do like a side-by-side box plot to show 5-number summaries? A lot of times in order to do that, you have to have all of your data in one column, so we could say like total number of appeals in one column. And then your groups have to have a grouping variable. So this would be my grouping variable, would be court, right? So then I could do a side by side by side, right? Because it'd be 3 of them box plot for these 3 different types of courts, and it would pick up the data just for the common pleas, right? And it would go from there, and then the domestic relations and so on and so forth. So it's a good idea to be able to have all of your data all in one column and then just have what we call grouping variables, a variable that tells you which group this data belongs to. Especially if you're going to be doing a lot of the same stuff for all of them, which we do. Here we want to know the probability of appeal and so on and so forth for all of our judges. And since we want to rank all of our judges, we need them all as just one big set of judges. The next thing I want to take care of is I want to take care of the fact that we have a 3A and a 4A, right? And I want to be able to combine those numbers because that's the same judge, right? This judge 3 and this judge 3A are the same judge. And one of the questions was, rank your judges. So you don't want to rank that judge twice. You want to give them just, one thing. You want to create one number for that judge so that we know where that judge sits as a total amount of appeals. I mean, you could let it stand this way, and you could rank the judge based on what they did in the common pleas and what they did in the domestic relations. But really, if you're trying to figure out which judges are good and which judges maybe shouldn't come back again, you want them to be merged together. And instead of looking at these individual cases and these individual cases, you kind of want to look at all 7,200 cases together and figure out what's happening. So my first instinct would be, well, let's put these things in order. And if I tell SAS to sort them, it does this silly thing where it doesn't know a 2 comes before an 11, right? So I'm going to undo that. And what I have to do is put a 0 in front of here. And then the nice thing about Excel, if I just grab this and bring it down, it changes all of them to 01 through 09. And now all I have to do is change this to 03 and do the same thing for 4, right? So find my 4A, there it is. Make that 04. Now, if I click on here and say, hey, sort ascending, it now sorts everything by the judge number. And really all that did was it put the 2 other ones kind of next to where they were because everything was already numbered by their grouping, right? You'll see that, oh, look at here. This thing is messed up because there wasn't a space. So let's fix that. And let's sort it again. And now it's back where it should be. Okay, so it's always a good idea to check things, right? That's an easy way to catch that whenever we typed in that judge 10, we forgot to put a space in between judge and 10. All right, let's deal with these repeats. So what I'm going to do is I'm going to Alt insert a row. I'm going to call this judge 04T for total. And as far as the court is concerned, I'll just put this as both. And then same thing for 3 and 3A. Now keep in mind again, if you're going to do side-by-side box plots and you want to show how things were done in each of the 3 courts, you're probably not going to want to label these things at all because then it's going to give you a 4th box plot for both. Well, maybe you want that, maybe you don't, but just keep things like that in mind. You can always, change things later. You can always delete stuff later, but this is just so you know what's going on. All right, so this number is just going to equal this one plus this one. Yes, I could have used the sum function, but it's only 2 numbers, so it's easier just to do that. And this is going to equal this one plus this one. Drag that across. So now we have all of them set up. Okay, now we can tackle this idea. Probability of an appeal. That's really easy. The probability of an appeal is basically just how many appeals they had out of how many total cases. So that's just going to equal appeals divided by cases. Simple. Grab that, drag that down, and there are your probabilities of appeals. Okay, probability of reversal, same thing, just equals number of reversals divided by total number of cases. Right, there, our simple thing for probability is always good over total. So the number of things that satisfy what we're looking for divided by the total number of things we're looking amongst, right? And then we've got this conditional probability of reversal given appeal. Remember, a reversal can only happen if an appeal has happened. So all of these reverse cases are basically subsets of the appeal cases. You can't just reverse something without having an appeal. Maybe that can happen under strange circumstances, but we're going to assume, and I'm not a lawyer, but I'm pretty sure it can't, but we're going to assume that that's the case for these, that these reverse cases had to first be appealed. So really the conditional probability of reversal given appeal just means how many reversals came from the appeal. So our good over total just changes very simply to this is going to equal number of reversals. And instead of divided by the total number of cases, it's just going to be divided by the appeals cases. So it says, almost 9% of the things were reversed, given that they already had an appeal. So it's kind of like saying 9% of the appeals were reversed. I mean, that's really what that is. Okay, so we did all of that. The last thing we have to do is rank our judges. And the nice thing about Excel is it has a really neat, easy formula called rank. And rank average is the new version, and just rank is the old version. If you have an older Excel, like you're dealing with maybe Excel 2000 or one of those older versions of Excel, you probably don't have the rank dot average, but they work both of them do pretty much the same thing. So we're going to double click on that, and then it tells you, what you need. So the first thing you need is the number. What are we ranking? Well, we're ranking this. They're kind of percentages of reversals, right? It wouldn't be fair to rank just number of reversals because a judge that had, 10,000 cases versus a judge that only had 2,000 cases, it wouldn't be fair to just say how many cases were reversed because that judge saw 5 times as many cases as the other. So that's why we have to basically rank them based on probabilities, kind of percentages, right? So we're going to rank on that number, comma, and then the reference is you're ranking a number from a set of numbers. So you need to tell it what the set of numbers is. So you're going to highlight this entire column of numbers like that, comma. And then the order ranks numbers as a reference where a list sorted in descending order or ascending order. So basically we want ascending because the highest rank should be given to the judge with the smallest number of things. And we can double check this. If it doesn't, you can check the numbers really quick and make sure that you did it the right or wrong way. Okay, so that would be, this judge's rank would be 8. And if we want to drag it down, it's not going to work because when we drag it, so for instance, when we come down here and click on here, um, look at what, so it's using that number, but it's using this huge, it's using the wrong set of numbers for the full set, right? It didn't keep the set the same. And that's what Excel does. It takes a pattern, and the pattern was this number divided by the set of numbers that starts at this number and goes, like 42 cells below. So in order for that pattern to hold, what you have to do is you have to hold these numbers steady. So your set, your reference numbers, you put a dollar sign in front of the 2 and a dollar sign in front of the 43. And now that locks it in place. And it says, okay, we can let this number change, but it's always going to come from the same group of numbers. And now if we do this, you'll see that It's changed. Now you'll notice these 0.5s. That's what the new version of Excel rank function does when you have ties. It takes um, how many things you have. It's like if you had two well, if you had somebody for in the 28th and 29th spot were tied, what they do is they take those two numbers and they average them, and that's why you get 28.5. I personally don't like that. I like the old version of rank better because what the old version of rank does is it treats ties as just the number. It's kind of like what we're used to. If you have someone tied for first and second place, they both get a one, and then the next number instead of a two is a three, right? There's no two. You just get one, one, three, and then it goes four, five, six. That's the way I like ranking. You'll see how it changes when I do this. You basically get rid of all the 0.5s. See? So instead of 28.5, it went down to 27. Okay. And then here's something I like to do really quick just to make sure that everything is okay. So I'm going to copy this. And then over here, I'm going to paste special because I want just the numbers. I don't want to paste the functions, right? Because if I try to paste, it's gonna try and do the functions, and it's not going to give me the numbers. I just want those numbers over here because I want to sort those numbers and make sure everything worked okay. And I just want to sort just that section. I don't want to sort the whole sheet. So now I can see what's going on. I had two tied for first, right? And as I scroll down, I can see, oh, I had a couple tied for 23, 23rd, right? I had these four tied for 27, right? 27, 28, 29, and 30. And that's why we had those 28.5s, because that would be the average of those four numbers. And see, I don't know about you, but I don't like that. I'd rather just see that they were all tied for 27. I mean, 28.5, what the heck does that tell me? And it doesn't help because it's not like it gave them all a different number. They were all 28.5s. So it's not going to help with any kind of analyses that you're running that, oh, I no longer have duplicates. Nope, you still have duplicates, but now you have duplicates that, have decimals. So whatever you guys prefer, that's up to you. I'm just giving you some of my opinions. Okay, so now I know that that's how everything works. All right, so I can delete that because I don't want that. We can also look around and make sure that this is the way we wanted it to happen. So for instance, I noticed there were a couple judges that didn't have any um, reversals. So shouldn't they be the best? Yeah, and they're both tied for first. So it looks like choosing ascending was the best way. We can also see that 32% is pretty high, and look, they were ranked 38th. And if we look around for the highest ranked, it looks like the highest ranked is 42, which is 0.5, right? Half of their appeals were overturned, right, or reversed. So that would be the worst judge as far as ranking is concerned. Okay, so that has cleaned up all of our data. It's all in one sheet. We would save this, call it whatever we want, and then now we should be able to upload this to whatever data set we want. All right, so this should hopefully help you guys with cleaning data, working with data. Just know that depending on what you want to do, you might want to come back and like delete these two um, rows, and then the same thing here, and look at just these as the both. But I personally would leave them there, right? Because you're thinking, okay, but look at the ranks, right? So they're ranked 27th in common pleas. They're ranked 35th for domestic relations and 32nd if you look at both of their courts together. Same thing here, 15, 22, and 17. You can see how it's kind of an average for both of them, right? If you average 15 and 22, you get 37, and the average of 37, right, is pretty close to 17, right? 17 is 34. So you can see that if you wanted to, you could just get rid of these two and just kind of take the average of their two ranks. The average of 27 and 35 is pretty close to 32, right? But I like it better to look at the raw data. And it just depends on what kind of analyses you want to run. But in any case, that's enough. We've covered everything we need to cover, and now you should be able to recreate this with whatever data set you have, and then upload it to whatever analysis software you're using. All right, good luck.